Okay, let's learn a little bit more about matrices. In the last lesson, we learned about a little bit of matrix operations, how to access information that exists in a matrix, but now let's learn how to initialize it, how to create it. In our lesson last week, we learned about how to create scalars, or how to create text as a variable, or even as a simple array, such as x equals 1, 2, and 3. And when we create an array, the key thing to remember is that the numbers are within a square bracket, like the ones you see here for array 1, array 2. But we haven't created a multi-dimensional matrix yet. So we need to learn how to tell MATLAB it's time to go to the next row. So if you look at array 1, we have our open square bracket, 1, 2, 3, and then we have a semicolon. This tells MATLAB, go to the next row. But I'm still in the matrix. This isn't to be confused with the semicolon you put at the end of the statement to suppress the information. Inside the square brackets, it means go to the next row. Let's do an example. We say array 1 is equal to 1, 2, 3. And we're ready to go to the next row. We use the semicolon, and we can say 4, 5, 6. Notice if I type the same thing but put the semicolon at the end, that will suppress the information. But all of the elements will remain the same. All right, so let's look at these arrays. We have array 1, which is 1, 2, 3 up top, 2, 3, 4 on the bottom row. And then array 2, looks like there's 5 elements in here. I guess you could just put a 9 for the second one, but they tried to trick you with a 2 plus 7. But what's going on with A? A, it looks like we're opening square brackets, but then we're adding information from array 2. So this first part says array 2 parentheses 3. Okay, this means that what's going there is the third element of array 2. Well, the elements of array 2 are 1, 9, 3, 4, 5. So the third element is 3. So really, MATLAB's going to put a 3 here. So it's going to go 3, 6, 7, new line, and then array 1. Interesting. So let's see what happens when we try it. We'll say array 1 is equal to 1, 2, 3, 2, 3, 4. Array 2 is equal to 1, 9, 3, 4, 5. 1, 9, 3, 4, 5. So now that we have the information, notice these are very different sized matrices, right? Array 1 is, if we come over to the workspace, it is a 2 by 3 matrix, whereas array 2 is a 1 by 5 matrix. So if we say A is equal to array 2 element 3, comma 6, comma 7, that's 3 elements. We have 3 elements on this first row. And then it asks for a semicolon, which means now we're going to the second row. And we're going to drop in a array 1. Let's see what it does. Okay, so it pulled the third element of array 2, which is 3. Then it added the 6 and 7. It went to the next row with the semicolon, but then it put in the entire matrix array 1. It happened to be the right size. It must have the same amount of columns, or else it would not have worked. Now here's a fun shortcut. I use this all the time. Last week when we learned how to create an array, let's say x. We say x is equal to 1, 3, 5, 7, 9. Notice that there's a pretty simple pattern here. It is the odd numbers, single digit odd numbers, 1, 3, 5, 7, 9. That's a simple pattern. The difference between each subsequent element is 2. So there's this shortcut here known as first, increment, last. We can use this shortcut to create an array that follows this format, where first is obviously the first number that we want in the array, increment. Those are the steps that we're going to take to go to the next element in the array. In this case, it's going to be 2. And then last, where do we want to end? We want to end at 10. So if we type this into MATLAB, MATLAB's going to say, okay, I want to give you a 1, then a 3, then a 5, then a 7, then a 9, and then, oh wait, the next one's higher than the 10 that you said was last. So I'm not going to go to 11, I'm going to stop at 9. Let's give that a try. We'll say x is equal to 1 colon 2 colon 10. Yeah. If we wanted to change that increment to 3, instead of going 1, 3, 5, it should go 1, 4, 7, 10. If we wanted to change the increment to 4, it should go 1, 5, 9. Now, you can also not add the increment value. You could just put 1 colon 10. This will tell MATLAB, I want you to give me an array that starts at 1, ends at 10, and increments to 1. MATLAB will default to 1 if you don't put in that increment value. And there you go. MATLAB also gives you a lot of built-in functions for generating arrays quickly. Here's a few we can try. Zeros, ones, EYE, and rand. And many of these have two different options. For example, there's 2 lines for zeros here. The first line takes in 2 inputs, m and n. If you remember from the last lesson, that designates a m row by n column matrix. Whereas the second option is just a single input, n. This tells MATLAB it is a square matrix. So when we use this function, MATLAB is going to create a matrix of all zeros that's this size, either an m by n or n. Ones is the exact same thing. There are 2 options, even though only one's listed here, but it's going to create a matrix of all ones with size m row and n column. The I function creates an identity matrix. If you remember what an identity matrix means, it's ones all the way down the diagonal from the top left down to the bottom right. All of the elements elsewhere are 0. And then the last one is rand, R-A-N-D. This creates a random matrix that's size m row, n column, and it will randomly give you numbers between 0 and 1. Let's try some examples. We'll say a variable called mat1 is equal to zeros of 3 by 6. There we go. We have a matrix that is 3 rows deep and 6 columns long, all zeros. Or if we wanted to use a single input, this tells MATLAB that the rows equals the columns, same number, all zeros. Same exact thing for the ones matrix. We say mat2, ones we want a 2 by 5, or ones of 5. If we wanted to use the I matrix, we could say maybe it's 6. It's a 6 by 6 identity matrix. Notice the ones going down the top left to the bottom right. All of the other elements are 0. Now you may be wondering, well, what if we don't have the same number of rows and columns? Okay, let's see what happens. What if we wanted a 3 by 5 identity matrix? Well, the ones will continue to go down until it hits something. It's either run out of rows or it's run out of columns, and the ones will stop, but the zeros will carry on. So MATLAB put a 1 on the top left, and they continued down to the bottom right, but there was not a 4th row, so there will not be a 4th one. Same thing if we did the reverse. 5 rows, 3 columns. Once it hits somewhere it can't continue on, it fills the rest with zeros. And then the last example would be the random function, R-A-N-D. This creates a matrix that's 2 rows by 7 columns with randomly generated numbers between 0 and 1. Now here's what's interesting. If you ran that same function a second time, all of your values would change. Notice that the first element in matrix 5 is 0.8147. It's not very likely that you're going to get the same exact result. And you don't. Kind of close, but it's 0.8003. Notice how all of the values change because you're using a randomized function. However, mat5 will always stay the same unless you rerun this function. All right. Here's an example I'd like you all to try. Let's go back to problem 5 of lab 1. Remember the error that everybody found? The error when they tried to square an array? Remember it was t squared in the equation and t was a 1 by 3. And you got this error that said, matrix dimensions don't work. We can't multiply this. You need to use a period before your asterisk. Let's see exactly why that is. So let's type out these arrays. So the first one is A1 goes 1, 2, 3, 4, 5. A1 is equal to 1, 2, 3, 4, 5. A2, don't remember, 2, 9, 3, 5, 7. 2, 9, 3, 5, 7. A3, minus 1, 1, minus 1, 1, minus 1. But then it's got this symbol over here. If you remember, this symbol means transpose. So it's going to flop all of the columns to be the rows, and all of the rows to be the columns. All right, so let's hover over in our workspace real quick. And if we look at this grid for A1, it says a 1 by 5 double. Same with A2. It's a 1 by 5 double. But even though it was typed out in A3 the same, we added that transpose. So this becomes a 5 by 1 double. So the first thing they want us to try is A1 times 3. Well, A1 is a vector, and the number 3 is a scalar. There should be no problem with that. So we say A1 times 3. And you guessed it, it's just going to multiply each element of A1 times the number 3. So instead of 1, 2, 3, 4, 5, we have 3, 6, 9, 12, 15. But now we said let's try A1 times A2. A1 times A2. Now before you even hit enter, if you remember from that lab assignment, both of these arrays are the same size, a 1 by 5, which means the number of columns in the first matrix does not match the number of rows in the second. So when you hit enter, you will get a runtime error. Incorrect dimensions for matrix multiplication. This does not work. Here's how we can fix it. Instead of typing A1 times A2, we can put a little period here. Now it seems like a simple fix, but what exactly does it mean? Well, let's look at A1 and A2 separately real quick. When we use the period, this means element-wise, element by element. So instead of the normal tricky matrix multiplication we did in the past, this is just going to multiply the first element of A times the first element of A2, which gives you 2. Let's look at the third one. It's a 3 times a 3. That gives you 9. Or a 4 times a 5, which gives you 20. Or a 5 times a 7, which gives you 35. So it's important to note if you're dealing with arrays, which we will be quite often, if they're the same size, you're going to have to use this period here, or you're going to get a runtime error saying that the matrix dimensions do not work. Now what about A1 transpose times A3? Well, A1 is a 1 by 5. If we transpose it, we're going to turn it in to a 5 by 1. Well, a 5 by 1 happens to be the same size as A3. So the same problem we just ran into, incorrect dimensions. This does not work. So the same way to fix it is A1 times A3, or A1 transpose dot asterisk A3. They both give you different results, but at least they can be performed. Okay, so we went through the first three on here, ones, zeros, and rand function, but D and E are some functions we have not learned yet. So D is using the reshape function, and E is using the diagonal function. So let's start going into MATLAB, and we'll plug in A, B, and C, and then see what we can do about D and E. So A is equal to 1s, 2 by 3. Okay. B is equal to zeros of 4. I'm going to suppress it with a semicolon so it doesn't take up too much space. And C is equal to rand 2 by 3. Now D says we want to reshape. Well, the reshape function, as you can see, has 3 different inputs. The first input is C. This means which matrix do you want to reshape? And then the second and third entries tell MATLAB what to reshape it as. So C is a 2 by 3, 2 rows, 3 columns, which means there are 6 elements in C. When you use the reshape function, the size of your second and third elements must match the size of the matrix. So if we want to turn it into a 6 row by 1 column, that just so happens to have the same number of elements, 6. So that would work. So we'll say reshape C into a 6 by 1. Now C has changed. Well, it's become D with a different reshape. We could also reshape it as something different. We'll say reshape C into a 3 by 2. Same number of elements. Or reshape into a 1 by 6. Those are the only options. If you try to reshape it as anything else, let's say a 2 by 4, it doesn't work. The number of elements must not change. And then finally we have the diagonal function. The diagonal function is very similar to the I function, EYE, where created an identity matrix. But if you remember the characteristics of an identity matrix, it has ones going across the diagonal and zeros everywhere else. Whereas the diagonal function, you get to specify what numbers you want going down the middle. So we'll say the first row, first column, I want a 4. Second row, second column, a 3. Third row, third column, a 7. Fourth row, fourth column, a negative 5. Now we have a 4 by 4 matrix because it will always be square. And the first entry is a 4. And then going down the diagonal, hence the name of the function, are all of the entries that you listed here. So accessing and assigning subarrays. So we just learned about the colon, right? When we were creating an array and we wanted the first and last, or the first increment last. Well, there's one more way that we can use the colon. We'll get to that in a second. And then there's the function end. It's not exactly a built-in function, so you don't need to put parentheses after it, but end tells MATLAB, go to the highest value. Let's see what we mean by that. So if we had A equal to 1, 2, 3 in the first row, minus 2, minus 3, minus 4 in the second row, and 3, 4, 5 in the third row. Let's use that colon. What exactly does this mean? Well, let's type it out. We said 1, 2, 3, minus 2, minus 3, minus 4, and then 3, 4, 5. I think I got that right. Yep. And then we wanted to say A2 was equal to 1, comma, colon. So that's interesting, because if you remember, when we're trying to access information from a matrix, we need to call the matrix name and then tell MATLAB, well, what part of this matrix do you want? Here's the most important thing for you to do. Identify your comma first. On the left side of the comma will tell you what rows to grab. On the right side of the comma will tell you which columns to grab. So on the left side for the rows, we see the number 1. This is saying I want only information from row 1. And then on the right side, which column, the colon means all of it. I want all of the information from column 1. Or sorry, all of the columns from row 1. We said row 1, all columns. And there we go. If we did the same thing but asked for row 2, we should get the second row, -2, -3, -4. Let's look at the next one. This one's a little bit trickier now. Now we're using the column to get all the rows or columns. In this case, we want all the rows. But now we're using the first increment last, which means we're starting at 1, ending at 3 in increments of 2. Okay, let's try this now. Let's show A one more time. And we're going to say A2 is equal to A. We want all rows. And then for our columns, we want to start at 1. We want to skip 1. And we want to end at 3. We're pretty much saying, okay, we want all the rows. But which columns do we want? We want column 1 because that's where we're starting. But we're skipping column 2 and then taking information from column 3. So we should see 1, -2, and -3 on the left in column 1, and then 3, -4, and 5 for column 2. And there we have it. Now let's use the end function. So here we're saying we want to create A4. We're taking information from A. Where's our comma? Here it is right here. Let's get this in MATLAB so we can see it more clearly. There's A. Now we want A2 is equal to A, 2 to end, and 2 to end. Did I get that right? Yep. So remember, the first thing you want to do here is look at your comma. Everything on the left of the comma is your row. Everything on the right side of the comma is your column. So which rows do we want? We want to start at 2, and we want everything after that. And for columns, we're going to start at 2. We want everything after that. So if we start at row 2, we're eliminating row 1 right off the bat. So now this is the only information we have to deal with. But then when we ask what columns we want to start at column 2. So we could have -2, -3, -4, and 3, 4, 5, but we're getting rid of column 1. So the -2 and the -3, the -2 and the 3 in column 1 will not show up. So the only values we should get are -3 and -4, and then 4 and 5. And there we go. And here's a tricky one. This one's very similar, but let's take a look. We're using 1 to 2 for our rows, and we haven't seen this before when accessing. We used this information when we were creating an array like 1 and 3, and that's exactly what it's doing here. So in this one, let's type it out. There's our A. A1 is equal to A. We want 1 to 2. And for our columns, we want 1 and 3. Yeah. So here we're saying we want rows 1 through 2. So right off the bat, the 3, 4, and 5 go away. So we have 1, 2, 3 up top, -2, -3, -4 on bottom. But we only want columns 1 and 3. So we should only get the 1 and -2 and the 3 and -4. Now, if you look at this example, what they did is they actually set those values to something else. So let's try it one more time, but we're going to do it a little bit different. So instead of creating A1 and setting it equal to part of matrix A, we're going to redefine matrix A, which means this is going to be on the left side of the equal sign. Now we're going to change the values in A. We're going to call it 10 and 11 and 12 and 13. Now if we look at A, the minus 3 and minus 4 should change to 10 and 11, and the 4 and 5 should change to 12 and 13. Oh, there we go. Now remember, if you do something like this, you're changing the values of A. So if you did not mean to do that, make sure that you're asking for the information, which is what the first four examples do, and not redefining the information. And the last part of this section is how to delete array elements. And we can do this by telling MATLAB that it's equal to open square brackets. That essentially means it is an empty matrix in that location. So let's create this matrix A, which is 3, 5, 8, 9, 1, 2. 3, 5, 8, 9, 1, 2. And we're going to say that A4, which is the fourth element of A, is equal to an empty matrix. Well, the fourth element of A is 9. So if we say A of 4 is equal to an empty matrix, that 9 suddenly goes away. We can do the same thing if we want to get rid of multiple elements at the same time. If we wanted to get through elements 2 through 5, well, that's the 5, the 8, the 1, and the 2. It should leave only the 3. Oh, I guess we should set that equal to the empty matrix. There we go. And the last example, we have B, which is a 2 by 3. We have 2, 4, 6 up top, 3, 5, 7 on the bottom. 2, 4, 6, semicolon to go to the new line, 3, 5, 7. And if we wanted to say that B 1 colon, what does this mean? It means the first row, all columns, which is essentially the 2, 4, and the 6. If we set that equal to an empty matrix, we'd be left with only the bottom row, 3, 5, 7.